Hello friends, welcome, and first of all, if you haven't subscribed to my channel, then please subscribe now. Now continue to the video. In this video we are going to make a multilayer perceptron with the Iris dataset using the TensorFlow library. So if you haven't visit my blog, then my blog is idiotdeveloper.tk, and I have written a post. Here is Iris Dataset classification using TensorFlow Multilayer Perceptron. So this video is going to be about basically this post only. So this is Iris dataset, which contains 5 things in his dataset. 4 are going to be our input, and 5th is going to be our output. That's we need to predict. So sepal length, sepal width, petal length, and petal width. So basically Iris dataset is a flower dataset containing 3 different species. So we are going to provide it with this dataset and train on it. So we have learned about the headers of the Iris. Now this is the Iris data. I have already separated the data into 2 parts. First is the training part and another the test part. So this is the test part containing 30 samples, 10 from each, and this is the training containing 120 data, like we can say. So now we are going to write the Python tutorial. So let's begin. So this line is to when we start working with TensorFlow, there is some warnings at the beginning, so we don't want that warnings. So to disable them, not to disable, just to disappear them, we write this line. Now our libraries TensorFlow STF. I don't think we need W, but still I'm important. If we don't need it, then we'll just remove it. Now we are going to convert this training data into a form that we can use it easily. So you can see we have one comma is separated by comma, individual lines separated by commas. So these first 4 features are for the input and this is for the output. So we need to put this in a separate array and put this in another separate, and we can't use it directly the name. We will convert it into an appropriate array. So first we are going to use that, encoding the label name, value that we are going to return. If label is equals to Iris Santosa, let me copy this. Then value is going to be 1, 0, 0. Else if label is equals to Iris versicolor, then 0, 1, 1, label is equals to, now the third, the last category, Virginia. Now we will return the value, not return, just value 0, 0, 1. Now we will return this val variable. Now it's for these four uh, variables. File name, the x, the y, and we all know what are the x and the y. So x is the input and y is the output. So first of all we are going to open the file. In the read mode, then a for loop, strip it and split. Now we are going to split it again using the comma. So now this line here, this line provides us with the individual line, with this each individual line, and then we split them by comma. So we have an array containing these whole values. Like if I just show you, print line, if I just file is equals to iris dot train def, or not def, data encode file. So I will run it, sudo python train.py. So you can see the whole list of the data set. Now we are going to split it again, and now we are going to have a data which is splitted, an array. Here we have individual line. Now next you can see we have an array. So these four are going to be our x and this is going to be our y, and we are going to use our label encode function to make it in an appropriate form. So x appending line 0, line 1, line 2, line 3. Now for the y, append label encode line 4. So now we are going to return x and y. So we have our train x comma train y. So this is one of the best feature of the Python, is that we can return more than one values at the same time. In other languages face some problems, and in such condition we need to make an array, and that's one of the best feature. Now let's see train x. If we have received, let me make it slightly longer. So you can see we have received the data and we have all the four variables. Now that's what we can do with the y and c. Now that's good, 1 0 0. So we have a training data and testing data both ready. Like this we can also get our testing data from the test iris.test file. Now let's continue this. Now we will create our multilayer perceptron, our model. X is the input, weights is weight, and the biases. Layer 1 is equals to tf dot add tf dot matrix multiplication between the x and the weights. So what I've just done is I have made the model, but I haven't defined the parameters. So first I think I need to define the parameters, then we'll continue with the model. So let's do one thing, leave the model here like this only. I'm just starting to define the functions first, but now I think it's necessary to just have the parameters first. The learning rate is going to be 0.01. The training epochs, we can say for the beginning we will keep it 1000. The display step, say 100, and now size of the input tensor is 4, and we are going to have one hidden layer, spelling mistake with 10 nodes, and the hidden output we know 3 nodes. And now the placeholders, x is equals to tf dot placeholder, and these are going to be float, none, and input. Like this we are going to define the y, placeholder, float, none, and output. So now we have placeholder also ready. Now we will define our weights and biases. Hidden and a tf variable, tf dot random normal, and an input, and the n hidden, because this weight is going to be deal between the input and the hidden layer. A comma, and we'll copy this because it's all the same, from n hidden to n output, because it's going to deal between the hidden layer and the output layer. Like this we are going to have the biases. So n hidden and the n output. So we have defined our biases. Now we have all our parameters, placeholders, the weight and the bias ready. Now we can continue our model function. Now here the weight is going to be hidden. Now you will get the correct point. If I write it first, so you will not get the point correctly. And here is the bias hidden. This is the layer 1. Then we are going to apply a redo here. Layer 1 on the output layer. TF dot matrix multiplication, the same but with a little bit different strategy. The output, Now here we will do on the plus sign. In the previous we used TF-add, and here we are using directly the plus sign. You can use anyway. Now we are going to return it, return the output layer. So we have our model ready. Now we'll continue with the training, the optimizing, and the most part. Let's define the model. We have left something, and that are the training and the testing data. So let's first define them. Train X, train Y, going to be the function name data encode. Data encode iris dot train test X, test Y, data encode iris dot test. So now we have our training and the testing data both here, and now we'll use our define the model X, the weights and the bias. Now the cost function, reduce mean tf dot n dot, and here we're going to use the softmax with cross entropy. Cross entropy with logits. Label is going to be Y. Now the optimizer. Optimizer is the Adam optimizer. Tf dot train dot Adam optimizer. The learning rate which you have defined above, and minimizing the cost. Now initializing the variable, tf dot global variable initializer. Now we are going to continue with our training. Now it's for the code which deals with the training part. In TensorFlow, the training began with a session. Session.run init, initializing all the variables. For epochs in range, training epoch. See. Session.run optimizer cost. So we are running optimizer cost both at the same time. Feed dict to give it the data. The X is going to be train X, the training data, and Y, train Y. Okay, now if +1 percentile display step is equals to 0, then print epoch as this epoch +1 and cost as simple C. So here we finish our optimization. Optimization finished. Now it's past part. Now this part. Now the next is going to be testing the accuracy. Now we are going to run our session on our model with the data. Session to run predict and then feed dict. X as train X. Correct prediction is going to be tf dot equal. Okay, here we are comparing the two things, tf dot argmax test result comma 1. Again tf dot argmax, this time train y comma 1. Now we are going to compare it and it will give us the correct prediction. How many of the, now this is the test result which is on based on the training data, and this is the answers or the output. These are the correct output and these are the predicted output. So if both are equal, this determine the accuracy kind of thing, how much accurate our model is. Accuracy is equals to tf dot reduce mean tf dot cast correct prediction as float. Now printing the accuracy of the test data. Accuracy dot evaluate test data. Oh, it's test X and Y on test Y. So I think this is completed in nearly 80 lines of code. Now let's run it and see if there's any error. So a problem, it's spelling mistake, and let me see it here. Sometimes spelling mistakes do a lot of problem, so I will just copy it from here and paste it here. Oh, there is some problem, size, the change in size. So you can see it just take nearly 2 or 3 seconds or maybe less than that. And how much iteration? We have 1000 iterations, and in 1000 iteration it has given 98% accuracy. So we can do one thing also. Just I have imported time and forgot to count the time. Start time, you can say, is equals to time dot time. So this will be the start time, and at the end we'll just complete time. How much is time to take complete this whole process is time dot time minus start time. Now we're going to print completed in complete time seconds, and we will run it again. Can see it is completed in 0.5 seconds. Now we have 97% accuracy. Let's run it again and it will give 97, 98. So If you want more accuracy, then increase its training epoch. You can also increase or decrease the number of, you can see 99% accuracy. You can see the increase the learning rate, or you can increase or decrease. So these are the various factors. But now the main thing is that we have got 99% accuracy, and if you want more accuracy, then we just train it like this on 10,000 POCs. I have a good GPU and this is small data set, and you can even train it on your CPU. There's no problem. You do not need any good GPU. So that's the best thing about this. It's good for beginners who are just beginning with the basics of TensorFlow. I also have a video on TensorFlow MLP, so check out this I button and see that video also if you are a beginner. So that's all for this video. I think you have understand the concept, and if this video is helpful to you, then please like it, share it with your friend, and subscribe to my channel. Thank you. Have a nice day.